Now we start new article, conservative and non-conservative forces. First thing we learn, what is conservative forces? So basically conservative forces are those for which work done depends only on initial and final points. So you note this thing. So work done depends only on initial and final points. So it does not depend on the path followed by the object. Means if so particle is moved from A to B by this path, by this path, or by this path, by three paths. I consider this is second, this third path. So work done by these forces depends only on initial and final. So if object is moved from A to B, initial point is A and the final point is B. So initial and final point is same, then the work done is same. So work done in case 1 is equal to work done in case 2 is equal to work done in case 3. I hope everyone understood what is conservative force. Example for the conservative forces are gravitational force is a conservative force. Electrostatic force is also conservative force. Now after that, properties of conservative force. So we have to learn the properties. Now let's see the first property here. So first property is when the force only this conservative force only dependent on initial and final position. The force only dependent on initial and final position, irrespective of the path taken that we already discussed. In any closed path, work done by conservative force is zero. For example, when we are talking about the circular motion, work done by conservative force moving object in this closed loop is equal to 0. The work done by conservative force is reversible also. You know what? Here work done is reversible. Then after that, we have to go forward and we have to start non-conservative forces. So opposite to the conservative, we have to discuss the non-conservative. Non-conservative forces we have to discuss. A force for which work done depends on path taken. So work done depends on path taken. Then that force is called as conservative force. An example is friction. So when object is moved from A to B, so I'm talking about here, if any object is moved from, so this starting line A to this line B by one path or by second path or by third path also we can consider. So in case of frictional force, so work this frictional force depends on the path followed. Maybe this path one may be a smooth and path two may be a rough. So friction in both the cases is different. So remember here, friction is a non-conservative force. And in non-conservative force, so work done by this non-conservative force depends on the path. Now let's see the properties of non-conservative forces. So first property is it is a path dependent. Path dependent. Therefore, it also depends on initial and final velocity. So it is a path dependent. So depends on initial and final velocity or initial and final position also. In any closed path, work done by non-conservative force is not zero. So when we are talking about a closed path, even the object is moved by non-conservative force in a closed path, then the work done is not coming zero. That is the work done by non-conservative force is irreversible. So this work done is irreversible. Now we have to learn potential energy. Now remember one thing is potential energy is the energy stored due to the position of object, and that energy is the potential energy. So here we can write potential energy is equal to minus means it is equal to the work done. The work done is stored in the form of potential. So minus F dx is written. So if work is done or the displacement is, the force is done